Example 6.48. Calculate the divergence at a point. In the example, we are given a vector field. The vector field depends on x, y's, and z's, has component functions p, e to the x, q, y, z, and r negative y, z squared. There's a typo in the book. We are asked to find the divergence of this vector field at a particular point in its domain. The computation for the divergence of a vector field is rather straightforward. We look at the component and put a partial on the component in the direction it corresponds with. Take the next component function and put a partial on it in the direction that it corresponds with. And the third component function, likewise, put a partial on it in the direction that it corresponds with. E to the x differentiates to e to the x, y, z. Derivative with respect to y gives us z. And negative partial of yz squared gives us negative 2yz. Easy. Plug in the value into this function, and we find that we get a positive divergence. In the previous video, we looked at a radial function which was directing all vectors towards the origin that had a negative divergence. They have a nice comment here that if our vector field represents the velocity of a fluid, then at this particular point, there is more fluid flowing out of the point than is flowing in. Why? Because we have a positive divergence. Excellent.